Hello, ma'am, your mic is off.
Yeah, thank you. So, welcome to the third session of FDP on cybersecurity in smart cities. I welcome Dr. Arup Kumar Pal as the speaker of this session. Dr. Arup Kumar Pal is currently working as an associate professor in the Department of Computer Science and Engineering, IIT ISM Dhanbad. Before joining this institute, he was a lecturer in the Department of Computer Science and Engineering, NIT Jamshedpur, from April 2011 to December 2011. He received his BTech in Computer Science and Engineering from Government College of Engineering and Textile Technology, Behrampur, in 2006. He did his PhD in Computer Science and Engineering from IIT ISM Dhanbad in 2011. He has more than 9 years of teaching and research experience. He has contributed over 70 research papers in several journals and conferences of national and international repute. His main research interest includes data compression, multimedia security, and CVIR. He has organized several FDPs in the area of image processing and cryptography. He has served as an advisor committee member and technical program committee member in various conferences, workshops, etc. Welcome, Arup Kumar Pal, sir.
Okay,
Now
thank you.
over to you.
Okay,
Over
thank
to
you.
you.
Thank you. Is it visible to all of you? Hello?
Yes, sir. It's visible, sir.
Okay, thank you. Thank you. So good afternoon to all of you. Myself, Arup Kumar Pal. So today basically discuss about the different multimedia systems and with respect to what kind of security you can preserve with respect to multimedia system. So this is the outline of our discuss about how to handle the multimedia data like image and video. In context of retrieval, how can ensure the security of this kind of data? So there we basically talk about the image data. So what does it mean in multimedia systems? So multimedia, that it is basically one of the systems that basically handle the different kind of data. The data may be text, it may be the image, audio, video, graphics, or animation. And where it basically objective is to how can we represent this particular data, how to store this data, how to transmit this data, and how to represent data digitally. So in this context of multimedia systems, we basically discuss about the multimedia content creation, storage and compression, multimedia communication, and multimedia retrieval. In the current scenario, the multimedia content is not that much major concern because in the current scenario, the multimedia data is easily available to everyone due to availability of the image capturing devices or video capturing devices. Now the problem is arise how to store this kind of data in a more concise way, because in a typical volume of the multimedia data like image and video is quite huge. So we need certain kind of approaches so that we can represent the data in a more concise manner. Now, if you can represent data in a more concise way, then definitely the communication aspect, it will be more easy to handle such kind of data. Now, in terms of retrieval process, in a retrieval, what we have seen, retrieval, we basically give some retrieval in a text data. So text basis, we basically have seen how does it perform the retrieval process. Now, the thing is that whenever you think about the images, this can be represented by some few words. So that is one of the challenging issues. So there we basically discuss about the content-based image retrieval. Now, in the context of security, how the retrieval can be performed in a secure manner. So that particular area is basically covered. So that means my objective in this particular lecture is that how to handle this kind of huge volume of data like image and video in a secure platform, because the theme of this particular is the surveillance of this data. So that means in a smart city, you need This kind of data is quite easily. This kind of data is always generated by in a smart cities but smart environment. So there, how can you handle this kind of data in a more effective manner? How can you represent? How can you store? And how can communicate this data? How can retrieve this data with context of the secure platform? Okay, so these particular things we basically try to address in this particular lecture. Now, first of all, we'll basically discuss the fundamentals of the images. So what does it image? So definitely, if you see this particular image, that is the one of the popular sentence that one picture is worth more than 10,000 words. So definitely, it is quite difficult to describe all the features of the image by a descriptive manner. Now, what computer understands what is the image? Now, this is the one of the left, the particular, just a minute. Suppose if we consider this particular image, so this is the one of the typical example of a binary image. So binary image basically denoted by the two basic intensity value. Either it may be black or it may be white. So how computer I understand, it basically stores such kind of data in a two-dimensional array, and wherever you have a white, we basically represent the value as a in form of a 1, and if you have a black, we are basically representing that particular value as a 0. Now, in case of grayscale image, grayscale is basically one of the variation of the different intensity levels. So we basically represent 0 as a pure black, and 255 is the pure white. In between 0 to 255, we have the different kind of variation. Now, in a real scenario, we basically use different kind of color images. Now, in color images, it basically having the three fundamental colors. It is the red, green, and blue channels. Now, RGB color component is there. Now, the question is that how this kind of natural images will be represented more concise way. So, first of all, we basically we'll discuss that color image quantization, one of the efficient manner, efficient approach. Basis on that, we can represent that kind of data in a more concise way. Now, what does the color image quantization? Now, in case of a color pixels, we basically represent the color pixel by the three components, that is R, G, and B. And each component is basically represented by 8 bits. So that means a particular color pixels is basically represented by 24 bits. So that means a particular color is represented by 24 bits. Now the question is that what will be the possible colors? The total possible colors will be 2 to the power 24. This will be the total possible colors. 2 to the power 24 is the total number of possible colors. Now the question is that our eye is not that much sensitive to this much colors. Yes, sir. That is the you can say that is the limitation, or you can say that is the advantage. Actually, this is the advantage that our eye is not that much sensitive to this much color. So now, representing my content instead of this much color, I want to represent the content. I want to represent my color image content by some selective color components. So that means here the color image quantization. The basic objective is that to represent your color image content basis on your selective colors. Now here we basically perform this particular process into two phases. One is known as the palette design process, another is known as the pixel mapping. Now what is the palette design process? The palette design process basically one of the approach here. It basically select a small set of colors that basically will be used in the later phase, how to represent that particular color in a color image in a more concise way. Now, pixel mapping is what in one of the mapping process. That means originally whatever you have captured, that particular captured have all possible colors, but our eye is not that much sensitive. So that in that case, how can you map that particular color with respect to your palette? Now, here I am giving one simple example, so that will give some idea. This is the one of the image. Now, suppose I have created one palette, and that palette having the two components, that is this one and this one. Now, what happened? I'll pick one pixel. So that means I pixel and map. Which one is the closest one? So that basically it performs basically the nearest distance. So I choose the one particular pixels, and that color pixels, and that parapixel will find out which one is the most closest one, and that particular color will be assigned to you. So this is the representation. Now, what is the advantage here? Now, whenever you are mapping each color pixel with respect to this one, since you have a two color component, so there is a two component, so that means I can identify if you want to represent that particular component by some indexing value, the indexing value will be 0 and 1. So what happened? Each color pixels, if you want to map with respect to two color component, so either it may be 0 or 1 index value. So naturally, what happened? Initially, you will get the one that index table. That index table having the two intensity index table. The component value will be either 0 1. So that means we are basically mapping 24 bit of data to 1 bit of data. Now, what will be the representation process, reconstruction process? Now, after receiving this particular one of the index tables, now index table will be mapped. Suppose if we say this is the blue color is 0 and this one is 1. So wherever you having the blue, wherever you having the 0, you just simply replace 0 by the blue. If you have a 1, you just simply replace by this particular colors. Now, if you encode in this particular manner, so you'll get this kind of images. Now, naturally, you'll say that definitely you are losing so many information in this particular content. So now, what will be the solution here? If we increase the number of significant colors, now see what will be the happen. This is the one of the image. There we basically taken initially one color palette, and that color palette basically consists of 128 significant colors. And after mapping this particular color with respect to this 120 significant colors, this is the reconstructed image. This is the same image reconstructed with a more number of colors. Here we have taken the 256 colors. Now, what is the advantage? What is the advantage here? Now, if we take the 128 colors, so that means each color pixel will be mapped with respect to 7 bit of data. If we map with respect to 256, that means each color pixel will map with respect to 8 bit of data. So that means if you think about how much compression you achieve, initially you have the 3 layer. Once you map with respect to your your code books, you are getting the one single index tables. And that index tables, each component value is only the 8 bit. So that means I can say that originally your color image having the 3 plate, now you can represent that particular component by the 1 plate. Now, what will be the reconstruction process? Where you have the particular index value, you just replace the corresponding index value by the corresponding color component is present in the code book. And this is the representation of this image. Okay. So here in this particular portion, you will get certain kind of distortion is there. But if you increase the number of colors, definitely your image quality will be improved. But if you take this kind of natural image, this is quite difficult to identify what is the difference between two images. Here, this is the image which is based on the 128 significant colors, and this is the another image which is based on the 256 colors. Okay. Now, in this particular process, what will be the compression? How much compression we achieve? Now, if we say, suppose this particular image is 100 by 100. Suppose this particular image is represented by this is suppose 100 by 100. Okay. Now, in this case, this particular image, we need to represent how many bits is required. Now, this will be 100 into 100 into 8, because each channel will be represented by 8 bit, and since there is a 3 bit, so it will be into 3. So that means 100 into 100 into 24. So this much this much storage is required to represent this kind of images. Now, once you perform the quantization, so right now you have each component is represented by 1 bit. So I can say that it will be 100 into 100 bits. Along with this particular table is required. This is called the code book. This particular code book is required in the receiver end side. How much bit is required to represent these things? It required the 2 colors, so that means it will be 2 into 24. That means 2 into 24, that is 48-bit color is required. So this plus 48-bit will be your compressed data. So what will be the compression ratio? Now compression ratio will be 1000 into 1000 into 24 divided by 1000 into 1000 into 1. That is this is the size of this index table plus 2 into 24, because in your code book you're having only the 2 colors, so it will be 2 into 24. So this will be your compression ratio. Okay. So the thing is that whenever we talk about the video data, so video data is always we basically prefer to represent the video data in a compressed form. The data in a compressed form, I'm giving one example, then you can understand. Actually, the video data is basically represented by a number of frames that will be visualized in this particular time span. So we can say that what is the video? Now each image in the sequence typically has the same property of width, height, and pixel depth. All of these parameters can be termed as the spatial parameter. Additionally, there is one more temporal parameter known as the frame per second of FPS. This parameter describes how fast the images need to be shown per second for the user to perceive continuous motion. So that means video is nothing but the sequence of static images, and that static images will be appeared to you as faster manner. As a consequence, you basically realize that particular appearance is basically is nothing but the moving objects. Okay. So here, video files, among others, have an extremely large data size that need to be protected from unauthorized access without affecting the transmission process. So here I am showing you one of the data. In this particular data, suppose you have a video part frame is 720 by 480, and each frame is again will be represented by 24 bit. And suppose you are visualizing this particular video having 30 frames per second, means per second 30 frames are coming. So as a consequence, you are feeling that it is one of the moving object. And suppose the total size of your video is 90 minutes. So here, if this is the approximate size is required to represent this particular video data. That means it required around 170 GB to represent such kind of video data. So can you imagine that whatever movie we are basically seeing that particular movie, whatever 3 hours movie, so I think if you store that particular movie in a raw form, so it will be more than 500 GB. So that means whenever you talk about the video data, we basically store the data in the form of a compressed form. So that's why whenever you want to view some video data, we need some kind of decoder. Like you say that we need some player. What is the meaning of this player? Player is nothing but, the role of the player is nothing but to decode the compressed data. Okay, so player will be decode the particular content. Like whenever you basically watch some kind of video in an online platform, so that basically stored the video frame in some buffer. If suppose the internet connectivity is lost in that particular moment, if some video frame is stored within the buffer, you can able to see this particular content. So that means whenever we basically see the video data, we basically not see the video data at a whole as a raw form. We basically decode the data frame by frame. Otherwise, what happened? This is a very low quality video. Even this particular low quality video, the video size is quite huge. Okay, so the question is that how to represent the video in a more concise form. So there are basically 3 kind of redundancy. Basically, see, one is the coding redundancy. Coding redundancy means how many times the particular things will be occurred. Suppose a particular things will occur more frequently. So there you basically use different kind of coding techniques. Like it may be the Hoffman coding, it may be the arithmetic coding, or you can use the dictionary-based coding techniques. So that basically utilize the occurrence of this particular data. Sometimes we basically compress the data with respect to their context. Okay, so context, like a particular pattern is more frequently. So that will be stored in this particular process. So there you basically is a different kind of dictionary-based coding technique. Sometimes what happens, we are unable to perceive the details of the content, like a color image quantization. Color image quantization, what we have seen, a natural color image can be represent if we represent it having the multiple is a huge variation of a color, but our eye is not that much sensitive to the distinguish this much color. So what happened? Limitation of the perception, we can we can apply the color image quantization. So that is called the psychovisual redundancy. That means visually you are unable to distinguish the differences between the detail of that much detail. That is called the temporal redundancy. Temporal redundancy is like that. I am present here, so there is a background. So the background is always fixed. Now suppose I am moving this my hand. So what happened? Most of the background content is same. Only if I say this is my object, this particular object will be moving in this particular certain region. So that means if you can recognize this particular object, so what happened? Instead of representing all the data of the background content, particular content is sufficient to deconstruct this thing. Now, what will be the decoding process? You just decode the background portion, and wherever the changes is occurring, you just basically focus on that particular changing region. Now, say for example, suppose I want to predict this kind of structure in my current frame. Already, there is a highly chance that such kind of structure is present in the previous frame. So naturally, I'll try to search within this particular region, and if it is present, so definitely I'll give the reference of this particular thing. Suppose I want to search one square, and you know that this particular square is size is suppose 50 by 50. Now we have observed this particular square in this particular position. Now what happened in this particular case? Instead of representing this particular content, we just simply take this particular reference coordinate. At that reference coordinate, if you just copy this particular reference from this reference coordinate, and if you paste here, so that will be give the visual perception. So naturally, we basically try to find out that particular object in the previous frame. So that means it basically takes the help of the previous frame, and basis on that we basically perform the we try to identify, try to explore the presence of redundancy. And that kind of redundancy is known as a temporal redundancy. Now, this is one of the examples here. Predict this particular object. So naturally, this particular object is not present in the same position. So that's how we have increased my search space, and in that particular search space. So that means if we see here, actually the actual location would be here, but the same content is available not in actual location if we see here. So here we basically see that a motion vector describes the offset between the location of the block being coded in the current frame and the location of the base match block in the reference frame. So here we basically try to exploit the temporal redundancy. Now this is one of the examples. Suppose I want to predict this. This is my current frame, and this current frame will be predicted with the previous frame help. Block 1 is not exactly present in this particular position. Block 1 is present in this particular position. Now, say if you want to consider the block 2. So block 2 again is present in this particular position. If you want to see block 3 is present in this actual position. So that means you will get almost all the content not in actual position in the previous frame in some. Now, temporal redundancy, basically, what happened? The temporal redundancy is basically in a short time span. Suppose I am moving these things, but if you take the continuous videos, if I am moving somewhere outside my room, so then you get the different context, but different structure. So we basically try to exploit this particular redundancy in a short frame. So this particular known as a group of pictures. So all frames in a video are divided into fixed size of groups called the group of pictures. Group of pictures, we basically distinguish the group of pictures into three categories, it having the multiple frames, and each frame will be basically distinguished into three different kind of frames. Either it may be the I frame, or it may be the pre frame, or it may be B frame. Now, what is the meaning? iframe is basically known as the intra-coded frame. It basically compresses whatever algorithm we follow in the image compression for compressing the image data. The same algorithm we follow to compress the iframe data. Similarly, if we consider the predicted frame basically encoded with the help of the iframe. Means iframe with respect to iframe, we try to predict the frame, and basis on that, it basically perform the motion estimation or motion compensation algorithm. Frame basically takes the help of the either previous or forward. Like here, I can say that iframe is there. Then another 3 interval region, there is another p-frame is there, another p-frame is there, and this is the one of the regions. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means this group of picture size is 9. In this particular frame, we are having the 9. This is the iframes. With this help of this particular iframe, it basically this p-frame will be encoded. And this p-frame will encode it with the previous p-frame. And in between iframe, p-frame, you have multiple b-frames, and that b-frames can be encoded with the help of the either iframe or it may be encoded with the help of the p-frame. So why b-frame is required? Now suppose I want to explore this particular structure. Now this is the target structure. Now if we consider the previous frame, this structure is not present. But if we consider the next frame, so this structure is present. So that means we try to consider the B frame. We basically exploit the information either from the I-frame or P frame. Now, whenever you want to represent data, so there we basically having the two steps: how to find out the motion vector, and basis on that, how can you perform the motion compensation. I want to show you one application where how the video data, the surveillance video data can be stored in a more effective manner. As you know that surveillance video is basically one of the systems that basically runs 24/7 minutes, and as a consequence, it basically produces a huge amount of content. Now the question is that how can you store this amount of data? Now, always whenever you want to store the video data, always you basically prefer to store the data in a compressed form. Now, if we apply the standard video compression algorithm, that will be work. But since it is a 24/7 system, so naturally there is a possibility that it will produce a huge volume of data. Okay, so here we need certain kind of approaches. That particular approach can, we basically see how that particular approach can reduce this kind of 24/7 data. Now here I basically show you one approach, and that approach based on the background subsection approach. And here you also introduce one adaptive group of picture-based concept. That means earlier the conventional video data, the GOP is basically fixed, but here we see that in our cases the group of pictures is basically changing. This particular group of pictures basically decided based on the object. Okay, so this is the model of this particular algorithms. First of all, it basically takes the video data, and that video data will be captured by some static camera. Suppose your camera is fixed in this particular certain location. So naturally, your background will be always fixed in this particular process. Now you just capture this particular background, and you just take the video data in a continuous manner, and you subtract this particular video from your captured background data, object data. Now this object data, suppose I am moving this particular hat. So this particular object is fixed in this particular frame. Now if you have a more number of frames will become, so that means that particular context will be changed. So that means you start another group of pictures. So that's why here we basically consider the adaptive group of pictures. As a consequence, if you have a group of pictures will be less, so definitely you can represent the data in a more concise form. Because we have seen that if you have a more number of group of pictures, that means you have a more number of iframes. If you have a more number of iframes, that means you have to compress that particular iframe in a conventional image compression algorithm. The number of group of pictures, so naturally it will reduce the number of iframes, as a consequence, it will drastically reduce the component. So here I'll show you how this particular works in a more effective manner and how it is efficiently represent the surveillance video data in a more efficient manner. So this is the one of the frame. This is the one of the background frame, and here your object is present in this particular position. Here your object is present in this particular position. Okay. Now, if you take the subtraction, and if you take although you are seeing that it's a black, but it is not a black, some difference value is there. And if you perform some thresholding here, so definitely you get such kind of binary image. Now, after opening and closing operation, you can remove those kind of unwanted noise, and you get this kind of structure. Structures, if you have a sort of multiple objects, like in this particular case, you have this is the one of the object, this is the another object, and we have subtracted from our previous background, and we have obtained this kind of objects, and we have taken the binary image, and after opening and closing operation, this kind of object is identified. Now here, different kind of connected component algorithms detect the number of objects present in a frame. Now, what is working procedures here? So we have basically computed a number of objects present in the particular frame, and basis on that, we basically divide the group of pictures. And once you know the group of pictures where the particular object is present, naturally, we basically try to encode that particular object region. Okay, so you just extract these particular object regions and basis on. So that means the number of objects present in a frame depends on the group of pictures. That is the conventional approach, but in our algorithm, we have considered the group of pictures basically decided based on the number of people are moving in this particular process. Now, this is the experimental results. You can see here. This is the MPEG image. That is one of the standard image compression algorithms. Standard video compression algorithm. And in this particular case, you have this much video dimension. That is 1080 by 1920 is the dimension of each frame, and it having the 384 component. MPEG process, you having the 42 video data, but if you consider multiple object-based representation, you are having the 39 video, 39 iframe. But if you consider the proposed method, you can reduce the number of iframe to 3, and also can reduce the number of iframe to 5 in the second category of data. Okay, so naturally, if you reduce the number of iframes, so definitely you will represent the data in a more concise way. So, what is the conclusion here? Now, in this particular process, the thing is that since the surveillance is one of the video is basically 24/7 process, and we have seen that the video data is a very huge volume of content. So naturally, we have to store the video data in a compressed form. Even the standard algorithm is also not satisfied the 24/7 architecture. So we need some kind of special approaches. Like in this particular cases, what we have seen that if suppose your static camera is fixed, and basis on that we can identify your objects, and basis on if you can identify objects, so naturally your background always object is remain same. So you just encode that particular object. If your object will be changed, so naturally you will get the more number of people will come in your objects, and naturally it will be changed. So that means the group of pictures will be dynamic. It will be not like a static. Okay. So still now we basically address one of the aspects. How can you store the video or image data in a more concise way? That means color images quantization is one of the basic approach that can be used to represent your color image in a more concise form, and also the video data must be represented in a more concise form, because the video data having the huge data. Okay, and once you compress this kind of data, so that is suitable for storage aspect, and that is also suitable for the communication aspect, and even it is also suitable for your security aspect, because security aspect, if you want to try to apply the cryptography in the whole data set, So that means rather than applying the cryptography in the raw data, it is always preferred to use the cryptography in your compressed data. Because if you apply the cryptography algorithm in a compressed data, so it will reduce the number of computation overhead. It will reduce the computation overhead of the cryptography process. That what is the challenges is presence in an image and video crypto system. Now we know that if we consider the AES algorithm, the AES algorithm, we know that there is no such kind of security attack is not possible because AES basically developed based on the DS algorithm, and we know that DS having the two major drawbacks is there. Defensive crypto analysis feasible on a DS algorithm, or linear crypto analysis is feasible on the DS algorithm. To overcome this kind of limitation, we have seen that AES is one of the standard algorithm, and if you have the number around more than 10, so then it is very difficult to perform any cryptography attacks on AES algorithm. Security aspect, we can say that AES algorithm is a secure one. Now the thing is that if suppose we have seen that AES basically works on only 128 bits. If it is works on the basis of 128 bits, so that means you are basically choosing very small amount of color pixels, and that particular pixels, if you want to encrypt by AES algorithm, this is the one of the example. It has been shown here, and you can see that although this was encrypted by AES algorithm, still the notion of this content is visible. Yes or no? Why it is feasible? Why it is visible? Now here the reason is that since the image having the more redundant content, that means similar content is present in the image data. So there is a possibility the same plain text blocks will be mapped to the same ciphertext block. As a consequence, it will give some meaningful content here. So there, if you see this particular right one image, there you can see that that particular image content is quite recognized by even using the AES algorithm. Now, then you can say that instead of blockchaining ECB mode, can you use the different kind of cipher blockchaining mode? So you can use the different kind of blockchaining mode. Now the thing is that if you choose the whatever blockchaining mode, if you select here, the thing is that overall computation is very huge, because even after the compression, it is very difficult to handle this kind of multimedia data in the conventional data crypto system. Okay, another problem is that that if you apply the conventional data crypto on this particular image, naturally there is a possibility that you will get such kind of ciphertext which is unable to hide the actual content. Now, what is the conclusion here? Now, standard block cipher are difficult to use directly in multimedia data. Multimedia are often of high redundancy, of large volumes, and require real-time interactions. And some real-time interacts applications such as live TV, mobile TV, encryption operations should be efficient enough to avoid service delay. That is another important point. That means whatever video you are watching in this particular process, if you compute your encryption process, it will be a time-consuming process. So that means it is very difficult to use in the real-time application. Multimedia data, some new encryption algorithms are required. They cover the various aspects, including security, compression efficiency, encryption efficiency, and format compiling. So these things must be addressed whenever you want to design any multimedia crypto system like image and video. So raw data encryption is required, compressed data encryption is required, partial encryption. Raw data encryption is rarely used, but sometimes raw data encryption is used for the medical images. But here we basically we do not use any standard encryption algorithm. We basically choose chaos-based different kind of encryption algorithm to make the encryption process faster. And if we choose the compressed data encryption, that is another very good solution. Or you can use the partial encryption. Partial encryption में क्या होता है ना? In case of partial encryption, we basically apply the different kind of transformation tools, and transformation tool basically transform the content from spatial domain to transform domain, And in transform domain, you can easily distinguish the content of the video data by image data in a significant and insignificant part. Now, what happened whenever you want to perform the compression? We basically try to discard the insignificant part. So here the thing is that if you want to preserve the content basis on some algorithm, you can also choose the partial encryption. Partial encryption means what will be happen? Partial encryption will basically identify the significant component, and that particular significant component will be encipher, and rest of the insignificant component may be sent as it is, or you can use some faster chaos-based crypto system to make the overall process faster. Basic steps. Original data, you can apply the key, you'll get the encrypted data. That is called the complete data, but rarely it is used for the image and video data. In case of another approach, you have original data, you just perform the compression, and then you encrypt with the key, and then you get the receiver will get the encrypted component. That is called the complete encryption. Partial will basically identify the significant and insignificant part, and that significant part will be enciphered by some key, and insignificant part will be transmitted to the receiver end as it is. So finally, you get this kind of encrypted data. Now, the system follow a confusion diffusion architecture. What is an architecture? You take the image and you shuffle the content based on some computation algorithm, and then you diffuse the means you just change the intensity value of this particular content. Our process must be iterated several times, so finally you get the cipher image. Now this particular this is the one of the example how we can extend our image crypto system for existing color images. Color image, if you want to apply the existing color image encryption process, and that first of all you take the input image, you divide the image into 3 color components, and from each component you apply this kind of confusion diffusion architecture based algorithm, and finally this particular outcome will be concatenated to form an encrypted image. Here, confusion diffusion architecture is basically a time-consuming process. So here you are basically using this confusion diffusion architecture in a 3 different color components. So definitely the overall computation overhead will be. To redo this particular process, in this particular process, what happened? We have taken this input image, and this input image is divided into color components. And after getting this particular color component, we basically divide each color component into corresponding bit plane. See what is the bit plane? In case of bit plane, we know that each pixel is represented by 8 bits. So if we collect the each position bits, and basis on that, if we form a image, so that will give some binary image, and that is called the bit plane. Bit plane. Now you just compute the bit plane for each color component, and you just shuffle the bit plane reorder. You just shuffle the content. Things you just take one 2D logistic map, and you take one of the key, and basis on this 2D logistic map along with the arc frame, and you just simply XOR operand. That is for the diffusion operation, and finally, if you concate these things, you'll get the shuffled image. And if you execute this particular process more number of rounds, so finally you get the cipher text. So this is the sum results, which is based on this particular algorithm. So here you have a buses. This is the cipher images. This is the cipher images, and this is the histogram, which is obtained based on this particular grayscale one of the art color component. This is the histogram of this particular color component. Blue is the histogram of this particular color component. After enciphering this particular algorithm, so naturally what happened, the standard crypto system says that your cipher text must be appeared in a uniform distribution. If histograms appear in a uniform distribution, in that case, it is very difficult to guess the original content, or it is very difficult to identify the key, because we know that one of the statistical attack is feasible. Like if suppose if we are using the different kind of business cipher. Business ciphers, we have seen that if you know the statistics of the content, then it is quite difficult to break the. It is quite easy to decode this particular message. But if your content is occurring in a more uniform distribution, then it is quite difficult to decode the content. So after the crypto system, after applying any crypto system in a particular multimedia data, so your cipher histogram, the cipher component must be occurred in a uniform distribution. Okay, so here we can see that this particular works having achieved the satisfactory results with respect to this algorithm. Want to extend this particular, still now whatever we have seen, we basically seen how we can apply the chaotic map based algorithm in a image data. Now we can extend this particular work how to store the VQ based compressed data. Now we know that the VQ based compressed data, we have a group of pictures, and in each group, each iframe is basically representative of all that particular group. Based compression algorithm, from that particular group of pictures, we basically identify the that particular iframe, and basis on that we basically create the code book. And after completion of this code book, we basically encode with respect to this particular input. And basis on that, we can show you that how we can achieve that. How can you design a crypto system based on the VQ based compressed data? Now, what is the VQ? Now, VQ is known as the vector quantization. Vector quantization, we know that we have a one code books, and basis on this code book, we basically map all the pixels with respect to the code book. Now, after mapping, we will get the basically one of the index table. What happened? VQ is quite popular because although encoding is quite complex, but the decoding is very straightforward. Once you know that code book, you just simply replace the corresponding index value by the corresponding colors. And if you represent this particular color image, it is quite difficult to distinguish. Like we already have shown you that 120 and 250 is quite difficult to show in case of natural images. So here what happened, in this particular works, we basically consider the iframe from each group of pictures. And basis on iframe, we have created one code book. We have created the n number of code books, and each intermediate code books will be mapped with respect to this corresponding iframe, the code book created from iframe. And basis on that, we basically identify the corresponding index value. Now, what is the advantage? Doing the motion estimation, but we are not doing the motion compensation because each color component of the video data is replaced by the index value. So that means in this particular process, we are not doing any kind of motion compensation. We are doing the motion estimation. And that means this index table will be transmitted to the receiver end. And once the receiver knows that particular code books, they can easily reconstruct the particular component. The structures, this is one of the structures. Here we have taken the input image, input video. That input video is converted into YCVCR component, and basis on that we have divided the group of pictures, and that particular group of pictures that code book created from the iframe, and basis on that all rest of the component are decoded and also reconstructed, and that means all the p-frames are encoded with the help of iframe. Frames are decoded with the help of p-frame. Okay, so this is the results. Now, in this particular process, at the time of storing this particular index value, the actual index are not stored. The index are stored based on some index are specifically stored in a encrypted form. So, as a result, if you take this particular video index value, so then you can able to create this particular video frames. But if you don't know the index value, so then it is quite naturally, it is quite difficult for you to locate this particular content. Okay, so this is the some results, and these particular results ensure that that crypto system can ensure this kind of video data. Although you know that vector quantization giving the huge compression ratio, and if we club together with the VQ along with your any logistic map based crypto system, so then it is quite difficult to the attacker to decode the original content. Okay, so this work process two contribution. Firstly, VQ-based video compression scheme is proposed, where all iframes are encoded using a codebook, and P and V frames are compressed using the decoded iframe. The main contribution that we have not used any motion compression process here. Only the motion estimation is enough to achieve the desired compression result. Secondly, a video crypto system is proposed on the compressed data. The scheme provides expected results using the Hanon map, which is used to create the confusion in the compressed byte stream and consequently encrypted it. Okay, so still now we basically discuss how to store the image data, how to store the video data. Then we have seen that how we can ensure the security of the image and video data. And there we basically seen that we basically follow this kind of architecture, that is confusion diffusion architecture, and this architecture is quite fast instead of using any standard encryption algorithm. Okay, and here generally, naturally, whenever you consider the image and video data, naturally prefer to the compressed data. Once you have a compressed data, and then you can apply this kind of algorithm. So naturally, it is quite difficult the attacker to decode it. Okay, and in case of partial crypto system, partial encryption, already have seen this particular case that partial encryption, some part, significant part will be encrypted. Those are not significant, can be transmitted as it is. Like one image, in a particular image, we know that each image is represented by either 0 to 255 intensity value. So the thing is that suppose you have an image, and if we apply the random coding, what happened? Now suppose you have a value like a 10 times 20 value is there. So we write down 20, 10. So that means 20 intensity occur 10 times. So that we can write down 20, 10. Similarly, in the next pixel having 240 occurred the 15 times. So you can write down 240, 15. That is called the random coding. Random coding, if you want to apply the partial encryption process, so in that case, if you simply encode the intensity value, so what happened? Suppose 20 was encrypted and it was now mapped to suppose 80. Now what happened? 20 comes in a consecutive 10 times, that will be replaced by the 80 by consecutive 80 will come in a 10 times. So that means that particular structure will be preserved. Whatever you have taken the content, the particular content structure will be preserved. So if you want to apply the partial encryption process, so here instead of encrypting the intensity value, you just encipher the random value. If you encipher the random value, suppose you have 20 occur 10 times. Now 10 is encrypted and now it is giving the 50. Now if you represent the 50 times of 10, so it will not give some meaningful content. So in that particular case, if suppose you are using the random coding, the random can be enciphered in this particular process instead of enciphering the original that particular intensity. Okay. So still now we have basically covered that particular things, two dimensions we basically covered, how in a concise form and in a concept of how to protect this data, how can apply some confusion diffusion architecture based algorithms so that that particular data can be protected from attack. Now we basically define. Now we'll discuss another aspect. This aspect is known as the content-based image retrieval. Now, secure content-based means I want to retrieve the content based on the secure aspect. What is the content-based image retrieval? Now, suppose you have this kind of image. Now, what will be the tagging information. Suppose I want to tag this particular image. This image, someone can say that it is a horse. No. Someone can say it is a tree. Someone can say it is a grass. Someone say it is a forest. Now, what will be the actual tag? It is quite difficult to tag such kind of images. Even this tagging is, even suppose you have millions of images, and if you want to tag manually, it is also difficult for you. So that means image have the perception visual presentation, and this phenomenon provides the motivation to discover tools for an efficient and effective searching, browsing, and retrieval of images. Traditionally, manual annotation of images and text-based retrieval methods are employed, which use tagging process for images. This is a time-consuming and brings a firm challenge to identify and requires a thorough study of the image content. Suppose somehow someone they have no knowledge of this particular image. They are given the different name of this particular content. So by intensely, it will come the different kind of image. Suppose you have an image of the Sachin Tendulkar, Saurav Ganguly. So then what happens? If suppose someone wants to search the Sachin Tendulkar image, now it will show you also the Saurav Ganguly image. So the thing is that that manual annotation is not a quite effective one. So we basically prefer to search, suppose if we give the input as a query image, and basis on that if we can perform the searching, and then it is known as a content-based image retrieval process. Now, what is the process of a content-based image retrieval? Now, suppose you have the image, user having a query image. So, first of all, it basically performs the searching in with respect to some database. Now, suppose you have a database, and each having in this particular database having n number of images, and each image having the one index, unique index value. Now, what happened? First of all, we extract the feature from the images, because if you compare image to image comparison, that is quite huge computation overhead required. Okay, so naturally, what happened? Instead of image to image comparison, we basically extract some salient component. Like suppose I want to say I need some good student. If we need some good student, if someone say all the details biodata of each student, so then it is quite difficult for us to identify some good student for some particular event. Now, what happened? Our common practice is that those having the 9-pointer, please come and meet me. So those having the 9-pointer, that means you are basically identifying certain kind of salient component. A basis on that, you are basically filtering this process. Now, what happened? Each image will be represented by some feature vector. Now, what will be the component of the feature vector? It may be the feature vector, maybe the information of the color information, it may be the shape information, or it may be the texture information, or it may be the statistical information. So that means your feature vector will be the one of the, it's not a representative of the original image, it's basically the concise component, and that is maybe the one of the unique component of this particular image. Okay, so first of all, we compute the feature vector. Now, your performance of a CVR solely depends on the construction of feature vector. If your feature vector dimension is more, naturally your computation overhead will be used. Number of feature vector, then you have to see whether the performance was compromised or not. So first of all, you compute the feature vector, and that particular feature vector will be stored in one of the intermediate database. And now user will provide some query image, and similar feature extraction process will be applied in this particular query image. Now you'll get the feature vector for the query image. Now, with respect to this feature vector, with respect to all the feature vector presence in this particular database. Now, you just find out some similar, according to the distance measure, which is having the minimum distance. You just identify those kind of, identify the indexes of that particular feature vector. And that index will be the that is the possibility that indices will be the indices of the actually the relevant images of the given query image. So after getting these indices, so basis on this, after getting these indices, the original images will be given to the user. Now the thing is that feature vector is from the feature vector you are not able to construct the original image. Just like if suppose you want to describe the one of the student characteristics, the GPA value is not the sufficient. GPA say, from the GPA I can't describe the what is the characteristic of this particular student information. But GPA say you can represent the like this the similar way. Like if you have a feature vector from we are not able to construct the images because feature vector dimension is quite small with respect to original dimension of the image. Okay, so after getting the indexes from this particular database, it basically provide the corresponding images to the user. That is the process of a severe problem. Now, what is the contribution for the researcher? Researcher point of contribution: how to find out the salient component, like what is the salient color, text, or shape will be the considered, and now the similarity measure will be the another consideration. Okay, so this is the consideration to retrieve this particular process. Now, in case of secure severe, so why the secure severe is required? Now, in the current scenario, what happened that in the medical science that all the data are basically stored in a distributed platform. But I want to search in a particular query, and that query will be searched from the different since it is distributed. So naturally, there is a possibility that that I have a some who know that the medical information is quite is a secret component. So whenever we search certain kind of information with respect to my case study, but of practitioner, we search some kind of information with respect to some kind of given medical images. So naturally, the retrieval must be performed in a secure way. Now, what are the secure aspect is there? The secure aspect is like that. Is that authenticate user can access the database. Okay, unauthorized user cannot access these things. So that means authentication may play one of the important role here. That means to design a secure severe. So first of all, you just authenticate user. So there you can use the different kind of authentication like a 1 factor, 2 factor, 3 factor authentication scheme is there. So I'm not going into the authentication area. That authentication was the initial phase. Once it is authenticated, now the thing is that secure, since your data is stored in a cloud, so cloud is not a private, it's a public place. So that means naturally I want to store the data in a encrypted form. Okay, now what happened as per the definition of a cryptography, the encrypted component does not reveal any kind of information. Yes or no? That means once you have an encrypted component, from that encrypted component, it does not reveal any kind of information. Now, what way the severe will be performed? The severe basically performed based on the similarity matching. So that means you are given one query image, and already the similar kind of feature vector is there. We basically compute the distance with respect to all the feature vectors, and those having the minimum distance, I can identify those images as my relevant images. Okay. Now the problem here is that your data is stored in a cloud in an encrypted form. Your query is also in an encrypted form. So that means you have to perform the retrieval in an encrypted domain. So that means you have to perform your similarity matching in an encrypted domain. But encrypted component does not reveal any kind of information. So that is one of the challenge here. Now here, instead of conventional, like we basically prefer the equivalent distance, instead of conventional equivalent distance, like suppose you are using the Hamming distance. And suppose if you are using the Hamming distance, the Hamming distance basis on that, you can perform this similarity measure even in an encrypted domain. In a Hamming distance base, how it is feasible in the Hamming distance base? Suppose your one of the feature vectors just a minute. Suppose your feature vector, this is your feature vector is there. Suppose this is a feature vector and this is encrypted by some key. This is the encrypted by some key. Query feature vector that is also encrypted by key. Okay. Now, if we perform the XOR between these two, equivalent to the distance between F and Q. So that is basically the similar distance between F and Q. Yes or no? So that means if we perform XOR between F XOR K plus XOR between Q XOR K, so finally that K will be cancelled out. So it will be the F and Q. So that means if we compute the Hamming distance between these two components, is equivalent to the Hamming distance between F and Q. So that means in encrypted domain, the Hamming distance basically preserves this kind of similarity measure. Naturally, there is another kind of KNN distance is there, some user basically use some weight-based distance. So first of all, let's see with respect to the Hamming distance base. Now, Hamming distance based process. So what are the issues there in a secure CVR? In security, the main challenge is to prevent unauthorized users from learning about the image data set and query relevancy, to develop a CVR method over encrypted domain that can protect user privacy without sacrificing usability and accessibility of the image information, and efficiency means privacy preserving in a CVR must not be disturbed the retrieval efficiency in terms of a retrieval time and accuracy. It should consider the image privacy of the image owner and the query privacy of the user. So here I am showing one of the three-party based CVR scheme. A three-party CVR retrieval scheme is proposed for medical image over an encrypted domain. Hamming distance is employed to measure the similarity as it is suitable candidate for distance measurement in encrypted domain than other conventional use distances. Now the thing is that whenever you want to apply the Hamming distance, so here we need the binary feature. Okay, so the binary feature is required, and here the binary feature is required in this particular process. A feature encryption process achieved based on the seed value, which is that is the thing. Like a three component is there: client, data owner, and that is the cloud server. Now, what happened? Cloud data owner having some images. That images are stored in an encrypted plus encrypted feature stored in a cloud server. Server will request for the some keys, and after getting these keys, it will send the encrypted query to the data owner. Now, data owner sent to the cloud. Now, cloud will perform retrieval process, and that will provide the encrypted image and also share the indices to the data owner. After getting the indices, the corresponding key will be shared to the client, and that will be given. So that now, after getting the corresponding key, now user can decode this particular message. The feature extraction process is shown here. That basically the visual silence is identified, and different red and green component. We basically compare different kind of statistical component we have computed, and this is the feature encryption process, and that will store in this particular process. And after getting this encrypted feature is given here. Now, this is the retrieval performance with respect to this medical data. So for the retina images, precision quite is high. For the other cases, it is not like a endoscopy. It is not that much good. This is the results of the top retrieval with the endoscopy. This is the retina images. Okay. Now, in this particular process, the major concern is that your retrieval must be performed in a encrypted domain. Yes or no? Because as per the definition of the cryptography, your data must be occurred in a uniform distribution. So that means if your data is an encrypted form, so conventional distance measure will not work. So in this particular area, what will be the contribution from the researcher? researcher contribution will be to find out suitable distance measure that can effectively work in an encrypted domain, and accordingly, you have to find out the suitable feature vector so that your retrieval performance must not be degraded, and overall your authorized user can allow to access your to perform the retrieval process. So that means here we need certain kind of cryptography authentication cryptography authentication mechanism is required, or cryptography authentication mechanism must be deployed in this particular process so that you can retrieve the relevant data in a secure manner. You also develop you can in a relevant way and efficient manner. So overall, in this particular lectures, I try to cover okay. So overall, in this particular lecture, I try to cover the three directions. One direction is that how we can storage, efficient storage is very, very essential because image and video is a huge dimension, huge volume of data. Main concern, if you can store the data in a more efficient manner, so that means the communication aspect is quite effective. Okay. Second thing is that how can I ensure the security? So instead of using any conventional crypto system, we basically prefer some chaos-based crypto systems. So that means in this particular area, if you search some research paper, that you'll get the different kind of chaotic map-based crypto system you can find out. That is basically designed for image and video data. I basically have covered that is the retrieval with respect to the image content. That is known as the content-based image retrieval. Okay, so here the retrieval must be done in a secure manner. Whenever you want to perform the retrieval in a secure platform, so there the suitable distance measure is required. So that is the challenge for the research. Okay, so right now it is open for any questions from audience sides. Any questions?
So participants, do you have any question? It seems it's clear to them. So thank you, sir, for giving us an insight of multimedia and how cloud can be incorporated for the development of smart cities. Thank you very much, sir.
Thank you, Dr. Mo, for inviting me for this particular question.
Sir, one question. Yes, there is one question. What's the scope of research in image steganography?
That is another dimension for the image communication. So image communication, what happened? Image steganography, what are the possible scope of research in image steganography? A different research paper is coming in this particular area. So basically working in the reversible data hiding. Reversible data hiding, what is the advantage is there? Like suppose you're using the medical content. The medical content, if you hide some content permanent, if you like a steganography is whatever mechanism basically use like a LSB or PVD that basically permanently destroy the content. So instead of destroying the content like a medical images, if you can extract the if you can preserve the original content if you require, but sometimes if you require you can hide some additional information. So there reversible data hiding is one of the area you can explore this particular area. Second question is that why should you consider, is it clear, steganography? Reversible steganography having lots of scope. And if you want to work in an audio steganography, in that particular area you have a lots of scope because like in image data, whatever you have embedded, that is very difficult to distribute. But suppose if you hide some content in your audio data, like suppose you are listening some song of the Lata Mangeshkar. So definitely you can, if there is some distortion is there, so definitely you can easily say that something is there. Okay, so audio steganography one of the possible area, or reverse steganography is the one of the possible areas. Why should we consider iframes? why should I consider B frames? When should I consider B and P frames? Actually, whenever you capture the video, so the video having the lots of similar sequences is there. So naturally, we divide the video in a group of pictures. So group of pictures, we can assume that in a particular group of pictures, the relevant frames are available. So with respect to iframe is basically one of the frames. We encode this particular frame in the conventional image compression algorithm. Now, what will be the decoding process? The decoder first decode the iframe. Now, they take the P frame. Now, this P frame will be decoded. That means this P frame will be decoded with the decoded iframe. Yes or no? So that's why. That means first we compress the iframe, then we compress the P frame, and then we compress the B frame. In the reverse end, we also decode in the similar manner. First we decode the iframe, then we decode the P frame, and then we decode the P frame. Okay. Necessity of the image steganography. Steganography you are using like a copyright protection. Copyright protection is one of the area that there you can use not in a form of steganography. That is the watermarking is the actually steganography is the part of a data hiding. So authentication is the one of the area there you can explore in these particular things. Nice session, sir. Thank you. What are the mathematical approaches to be very strong in this particular area? Suppose mathematical like a feature extraction is one of the area. If you want to work in the content-based image retrieval, but if you can work in the machine learning or you can use the deep learning in this particular area. Cryptography is one of the area. Cryptography you can use like a conventional cryptography may not be used directly as it is. Like I already shown you that one of the areas, although it is the standard algorithm, but even it is not suitable to encipher image data. So that means you have to think about some different kind of approaches. If any open source software tools are available, MATLAB, in the student scenario, MATLAB you can easily handle. In the MATLAB, if you want to do certain kind of research in the video data, the MATLAB is also sufficient to do this kind of things. It was a nice session. Thank you. Thank you.
It was really a very nice session, sir. Thank you.
Okay. Thank you, Dr. Mo. Thank you.
Okay. So, dear participants, that's all for today.
Okay.
We have completed the 3 sessions, and tomorrow our first session will start from 10:30 a.m. So there is the participants are still now writing about your session, sir. They are very much impressed.
Okay. Thank you. Thank you. Thank you.
Okay, so participants, be there positively at 20 minutes past 10. Okay, so that we can start our session on time. Yeah, attendance is taken care from our end only. No need to get worried about the attendance. It is recorded and I'll do the needful. But the feedback you have to provide from your ID in the Atal portal. Okay. No need to worry about your attendance. It's being recorded by our application. The attendance are there. Thank you. Thank you all.
Thank you. Thank you.